what the group at GM had to do, the group under Greg Becker and Frank Pavlik's and the people working with him, they had to come up with wheels and traction techniques that would work on that lunar soil unlike anything known on Earth. And so the contribution of my concept to the lunar vehicle, I would say, was 25%. The big contribution was to the locomotion.
Thomas Putnam was born on the family ranch in Petaluma, California on June 23, 1903. He had 2 younger brothers, John, who became a professor of engineering at the University of California, Berkeley, and his younger brother, Rutherford, who would ultimately own the local Chevrolet dealership in Petaluma later in life. Rutherford's wife, Helen, would later serve as the mayor of Petaluma and reside on the board of the Golden Gate Bridge in San Francisco. The father of the boys died in 1915, so they were raised alone by their mother, who was a grade school teacher. Quite possibly the most educated family that we have ever interviewed, the entirety of which is brilliant, 2 of which graduated from Berkeley, 2 of which graduated from Harvard, and 1 that went on to be a rocket scientist. That's a true story. Tom attended the University of California, Berkeley, and majored in mechanical engineering. It was there that he met the love of his life, Charlotte, and the 2 were married on June 6th of 1928. While at Berkeley his freshman year, Tom saved a young girl from drowning in the treacherous waters of Tomales Bay outside of the Golden Gate Bridge. This act of heroism earned him the distinction of receiving the Andrew Carnegie Medal of Heroism 3 years later. In addition to receiving the highest honor allowed to a civilian in peacetime, he received the sum of $5,000 from the Carnegie Trust. Adjusted for inflation, this was enough money for quite a home in 1927. The inside joke within the family was that Tom had struggled to pay for school, and now that the degree was obtained, he had struggled in vain. Tom graduated from Berkeley and immediately took a job with General Motors. He was transferred to Oakland, California, where his career started. By the time 1934 rolled around, Tom had become his own service manager with his background in mechanical engineering and his experience with General Motors. In the early years of World War II, Tom was transferred to Detroit and worked in the same tank mobility division as Frank Pavlik's and Dr. Becker, 2 of the men that are currently accredited with the design and build of the final version of the Apollo lunar rover. Frank was tasked with soil testing, while Tom was dutifully designed to train personnel how to service the new designs. They ultimately achieved a tank with wheels on the front and a tracking system on the rear that could be driven at high rates of speed and was more agile in the war efforts in North Africa.
Camouflaged, the tank destroyer races to make-believe attack at battle speed. A jeep cuts across the tank destroyer's path. It skids and comes to an abrupt halt. The track has been thrown. It has to be replaced without lost motion. Only 2 men are needed, so the others can spread out and stand guard while the mechanics go to work on the track. And the well-coordinated job is done. A new record has been set, all right. They've replaced the thrown track and the vehicle is rolling again in 9 minutes. It's a record for half-track men everywhere to shoot at.
After the war, Tom was promoted to National Service Director and remained in Detroit. His image graces many historical GM documents and functions throughout his tenure. It was during his tenure that another highly sensitive venture was being undertaken by General Motors. In the final stages of the electric vehicle designs and builds in Santa Barbara, California, the program was moved back to the General Motors Technical Center for final touches. The leaders of this division, Donald Friedman and Dr. Paul Agarwal, and their remaining staff that had agreed to relocate, resumed their involvement in the very first high-performance battery electric passenger cars within the confines of the General Motors Technical Center until completion. Independent from these creations was their electric drive and mobility systems that were receiving final touches for the lunar roving mobility test units.
What would it be like to be on the moon? A question that has intrigued men since long before the invention of the telescope. To travel across the roughly marked surface of our nearest neighbor in space is an experience that men will soon be having. Probably before this decade is over, the first explorers from Earth will have arrived on the moon. But how will they explore a planet without roads, without atmosphere, with gravity, only 1/6 that of Earth?
I was asked in 1963 by Don Friedman to recommend an electric drive for the lunar rover. And I right away recommended a DC version of my concept, and it ended up on the Surveyor test vehicle.
Enter the F-Car, the vehicle we all know so well today as the Camaro. It was a new product line slated to be started in the summer of 1966, and the early days of design are known well by many. However, one elusive fact has gone unnoticed until this research. 4 of the initial pilot prototypes were slated for mock-up and testing by Paul Agarwal's electric drive division. These pilot prototypes were number 28, 29, 30, and 49, respectively. It was during these summer months that these cars were outfitted with individual components to test feasibility and reliability of their electric drive systems and their individual electronic controls. These components would ultimately find their way to the construction and build of the Lunar Roving Mobility Astronaut Training Test Unit. During the time that Frank Blue and General Motors were creating and instituting the F-Car pilot prototype program in April and May of 1966, NASA was hiring 19 astronauts for their upcoming missions to the moon. Frank would name Tom Putnam, the General Motors National Service Director, to work as a liaison for this program.
That the Camaro was used by the people, the engineers who reduced my concept to practice as a test bed because it was convenient, they didn't have to pay a lot of money for it, and they were able to do some testing on the Camaro, not of the electric drive concept for automobiles. It was for the electric drive concept used on the lunar rover, which was also a General Motors electric drive, which borrowed quite a bit from my concept. I think that's how the Camaro got into the picture, as a test bed for the lunar rover electric drive.
Reliability and error had to be limited to a 99.9% success rate. These vehicles were first subjected to creating a real-world weight study to achieve a desired weight of 1,400 pounds for a test vehicle. Consequently, they were delivered by the pilot program without a drivetrain. At the Tech Center, the interior and doors were removed. Every piece that could be removed and still have structural integrity was.
From the interview of George Spix that resulted in episode 11, a colorful story was painted. When they announced that the division was going back to Warren, a lot of engineers quit. Those that didn't either went to Delco Products or were chosen to work with Pavlik's. He would go on to say, another short straw was stripping those yellow Camaros down to make weight for testing. We had no operating budget after Santa Barbara, so the cars were loaned to us. I had helped disassembling them and putting the pieces in storage, but that was the easy part.
With reliability on the moon closely held at 100%, Dr. Paul Agarwal and Dr. Herbert Woodson tested the mobility systems in this testbed. The system included wheels, traction drive, suspension, steering, and driving control electronics. The batteries were already designed and tested in the creation of Electrovair 1, and it was thought that an alternative power source would probably be necessary because of their weight. Consequently, these vehicles were tested with batteries that were installed remotely. The batteries were connected to the vehicles with a traveling umbilical cord of wires. This design would ultimately make its way to the Lunar Roving Mobility Test Vehicles. One of these vehicles was used to train astronauts Louisa and Carr how to maneuver and drive it in the dunes of Pismo Beach, California in 1968. In addition, retired astronaut John Glenn would be briefed by Dr. Paul Agarwal at the General Motors Research Center 5 months prior to the Apollo missions. Because of the limitations of Earth technology being tested for lunar use, it was difficult to simulate conditions. The final version would operate in 1/6 the amount of gravity, so it was a process of physics and mathematics that verified whether this testing would even work on the moon. The final weight limitations of this vehicle were speculated, but not known conclusively. The final overall dimensions of this vehicle were not known as well. Consequently, the focus was maintained on the electric drive systems and the components that controlled them. Due to the sensitive nature of these activities, Paul would not be formally recognized by General Motors for his involvement in these programs until May of 1968, the exact same time that the Lunar Roving Mobility Test Unit was finished. Additionally, when his thesis papers regarding the original electric drive patent by General Motors were published and distributed, showing an additional application in lunar vehicles and responded to, his response was akin to, "Check the scoreboard, boys. General Motors is going to the moon." Tom Putnam's name, as it appears in the FCAR pilot book, represents the crowning achievement of his career. Because lunar mobility had to operate outside the prying eyes of people not debriefed, some of these budgetary responsibilities fell upon the National Fleet Service Division. Tom oversaw the operating expenses of this division. The 4 FCAR pilot prototypes that were initially scheduled for electric drive testing utilized the high budgetary restrictions of the National Fleet Division, but that money was actually used to develop and test components necessary for the mobility test vehicle that was utilized by astronauts in the summer of 1968. Because of his clearance and insider knowledge, Tom worked as liaison for this program until the entirety of Agarwal's designs were fully engineered and tested. He retired shortly thereafter and received a diamond retirement ring. This ring would ultimately be used by his granddaughter Nina in her upcoming nuptials to his grandson. Tom and Charlotte retired to Grand Junction, Colorado, where they lived happily below the mesa until their deaths in 1976 and 1987.